take a closer look, I've come to Switzerland's Sphinx Observatory. Perched precariously on the Jungfrau Mountain. At nearly 3,600 meters, it's one of the highest peaks in the Alps. And after the sun has sunk below the horizon, it's a great place to gaze at the stars.
Well, it's a really clear night, so you can see loads of stars. There's Sirius over here, the brightest star in the night sky. And then right here, really recognisable constellation, which is Orion.
So have people always picked out Orion as a significant pattern in the night sky?
Well, it seems like different cultures all picked out that group of stars as being a significant one, and they all have different legends about it. So the Egyptians associated it with Osiris, their god of death and rebirth. Other cultures also grouped them together. A Native American tribe called the three stars of the belt the three footprints of the flea god, and one group of Aborigines in Australia called it the canoe.
Today, we don't need legends to explain the patterns in the stars, because we know their precise positions in space. And we don't just know where they are now, we know where they were yesterday and where they'll be millions of years into the future.
So the Sun and all of the stars in our galaxy, including the stars of Orion, are all moving in orbits around the centre of the galaxy. But a bit like a swarm of bees, although they're all moving in roughly the same direction, they all follow their own paths. And that means that their positions in the sky will start to change as thousands of years tick by. And now we're 2.5 million years in the future, and the constellation of Orion has completely gone. And in fact, thousands of years ago, our ancestors would have seen different patterns in the sky, and our descendants millions of years in the future will also see different patterns.
The reason we can predict how the stars will move into the far future is because we've uncovered the rules that govern their behaviour. And we've found these rules not in the heavens, but in numbers. It's only through the code that we can understand the laws that govern the universe. Laws that describe everything from the motion of the planets to the flight of a projectile.
When you watch the fireball fly through the air, then it appears in the first part of its flight, when it's just left the trebuchet, that it's accelerating upwards. And then it begins to slow down before it stops just above me, and then finally accelerates back down towards the ground.
But if you analyse the flight using numbers, it reveals something rather surprising.
When you plot a graph of the projectile's vertical speed against time, then you get a graph which looks like this.
To start with, the projectile is travelling upwards, so its vertical speed is positive, but decreasing. As it reaches the top of its arc, the vertical speed becomes negative as the fireball turns round and falls back to Earth.
Because the graph is going like this, it means that the projectile, from the moment it leaves the trebuchet, is actually slowing down. So at no point during the flight is it ever accelerating upwards.
Throughout its flight, the fireball is in fact accelerating downwards towards the Earth at a constant rate. Something you would never realise simply by watching it fly through the air. And this is a profound truth about one of the fundamental forces of nature: gravity.
Drop, throw, fire or launch anything you like, a rock, a bullet, ball or even a pot plant, and it will accelerate towards the ground at a constant rate of 9.8 meters per second per second. This is a fundamental law of gravity on our planet, but it's only revealed by changing the flight path of the object into numbers.
Appreciating this simple fact about how gravity works on Earth is the first step towards understanding gravity everywhere. It's the foundation stone of Newton's law of universal gravitation, a mathematical theory that can describe the orbits of the planets, predict the passage of the stars into the distant future, and has even enabled humankind to step foot on the moon. The laws that command the heavens are written in the code.
We call them doormats, the large ones.
2.5 million years in the future.
This isn't imaginary, this is real.
This is very real.
You don't need to know what that sound means to know that that animal's not happy.
Whatever circle I take, you're going to get a number which starts at 3.14. It's an incredible thought that the only way that we can really make sense of our world is by using the abstract world of numbers. And yet those numbers have allowed us to take our first tentative steps off our planet. And they've also given us the technology to transform our surroundings. A hidden code that underpins the world around us. A code that has the power to unlock the laws that govern the universe. This place was constructed to satisfy a spiritual need, but we couldn't have built it without the power of the code. For me, it's an exquisite example of the beauty and potency of mathematics.
From the patterns and numbers all around us, we've deciphered a hidden code. We've revealed a strange and intriguing numerical world, totally unlike our own. Yet it's a code that also describes our world with astonishing accuracy. And has given us unprecedented power to describe, control, and predict our surroundings.
The fact that the code provides such a successful description of nature is for many one of the greatest mysteries of science. I think that the only explanation which makes sense for me is that by discovering these connections, we have in fact uncovered some deep truth about the world. That perhaps the code is the truth of the universe, and it's numbers that dictate the way the world must be.
To take a closer look, I've come to Switzerland's Sphinx Observatory. Perched precariously on the Jungfrau Mountain.
Well, it's a really clear night, so you can see loads of stars. There's Sirius over here, the brightest star in the night sky, and then right here
In the Alps. And after the sun has sunk below the horizon, it's a great place to gaze at the stars.
a really recognisable constellation, which is Orion.
So have people always picked out Orion as a significant pattern in the night sky?
Well, it seems like different cultures all picked out that group of stars as being a significant one, and they all have different legends about it. So the Egyptians associated
At nearly 3,600 meters, it's one of the highest peaks